Welcome everyone, and thank you for joining us today. Our topic is shaping data into required results, the power of structured information, explored through Woodwork for Inventor software. In woodworking and furniture design, the way we organize and structure the design data can greatly impact the efficiency and accuracy of our projects. So today we'll see how Woodwork helps us to generate template-driven bill of materials, cutting and material lists. Please note that this presentation is a conceptual overview. It's not a tutorial, so if you have any questions about how Woodwork works, feel free to reach us at info@woodworkforinventor.com, and we will be happy to provide additional insight and assistance. So now let's outline what we will be covering today. We will start from importance of data organization in modern society, especially using relational databases. We will see how unorganized data can hinder decision making, how it can affect our performance in woodworking, and so on. Then we will see what informational model exists in different systems, like in mechanical CAD systems, like Autodesk Inventor, Fusion, etc. How the data in a hierarchical structure can help us to generate bill of materials. And also we will see how it happens in woodwork, how we can assign materials to components, how we can work with the parts and workpieces in order to get the data that we need for manufacturing. Okay, so the data processing in general CAD differs from processing in woodworking CAD systems. We will focus on how to manage the data extraction from the model, how to generate reports, what is the role of hierarchical data structures, how the templates can help us to get data in the way that we need, how we can tailor the data for the reports for different manufacturing stages, and so on. Also, we'll see what report templates are available in the software, how they function, what we can do with the templates, how we can adjust the data shape for our needs. We will see how the template works in terms of keywords, how we can adjust the keywords to make the things work in the way that we need in order to generate various type of reports. Okay. In the second half of our presentation, we will see how we can do some practical things, how to develop some BOM using a task as example. And we will finalize the presentation with a discussion about the BOM APIs for those advanced use cases. Okay, so let's begin from overview. What we need to do with the data, because modern society generates a vast amount of information, and you can see that in the year 2000 we generated about 2 exabytes. So now we annually generate about 70,000 times more. So, and what makes it even worse, that 90% of the data was generated in 2 years alone. So that raises the question how we can structure and organize the data, because just having the data is not enough. Without proper organization, raw data holds little value. So we need to find a way how we can process the data, how we can perform some queries in order to get the data that we need from the just a data set. So if we're speaking about the informational models, CAD system typically have following data types. Working on the part, you are working on the features, which allows you to define the shape of your part, gradually refining what features should be presented. If you're speaking about assembly, then we can combine parts together using constraints in order to define the position and connection between 2 or more parts. And finally, what we have is an I properties, is an informational data block connected with the part or assembly that allows you to understand some additional properties, like say a revision number or some description and so on and so forth. Okay, so speaking about the way how we can get the BOM out of the CAD system, typically we see 2 types, like structured and parts only BOMs. The first one allow you to understand the role of the part within the assembly, because your assemblies can be made of multiple blocks. So the first one shows you where is the position of exact part within this big data structure. Second, though, works differently. It collects identical parts together and quantifies how many identical parts do we have, and thus allowing you to get a task for supply chain and so on. If we speak about woodworking, things becomes a little bit more complex because components are not made of a single material. In a furniture, a part is viewed like a small assembly of glued semi-finished workpieces. Okay. Once we work with Woodwork for Inventor, when we assign the material, it creates additional data structure that links workpieces and parts together. And the size of each component is influenced by the grain direction, oversize, the edge banding, the type and position. And moreover, if you work with composite parts, then we have even more workpieces of a different types. Let's say we have a profiles in the center, and those profiles are measured by length. We have boards on both sides. They are measured by area. And finally, we may have something else, yeah, like say a cover materials, which can also be measured by area if they are veneer sheets, or they can be measured by length if they are edge banding. Okay. Extracting information about the furniture workpieces is a routine yet essential process. Our analysis highlight that in conventional workflows, twice as much time is dedicated to generating manufacturing data as to focusing on actual product design. So you can see that, for instance, we spent like 30 minutes on some simple model, and we can spend about an hour or even more on defining the BOM for that simple unit. Yeah? And things became even more complex if you're speaking about more advanced design. With Woodwork for Inventor, we can cut the total time in half, reducing the time spent on manufacturing data preparation to just 10%. This enables more efficient workflows that allows creation of more refined and sophisticated designs. And so we have more time on making some more detailed products, which allow you to gather the data out of them. Okay, and this is achieved in large part by automating the output of bill of materials, significantly reducing manual efforts that you need to put into the model. Okay. In Woodwork for Inventor, the model serves as a single source of the data. That's very important because there might be some side workflows which negatively impact the performance and quality of the data. Okay, and in this case, all the things that you include in the model during the modeling stage will be calculated. They will be taken out, filtered through the template, and finally this template defines, it shapes the way how the final report will look like. We categorize reports in three main types: structural reports that represents the product structure, flat reports that provide a list of parts, and finally material summaries that outlines the material quantity used in the product. Woodwork for Inventor uses a keyword system to define report template. Okay, we have keywords that can act like operators in a programming language to retrieve specific data. For instance, the item code can get the part number from the model. And using those keywords, you can get the access to all the data structure that we have in a model. Typically, reports are generated using Microsoft Excel, but you can also export the report in different formats. So now let's take a closer look how Woodwork for Inventor template works. The type of the template determines how the data model is processed. For instance, when we generate a flat report, assembly type components are ignored. So you can see in this screen that on the top corner we have structured list, BOM part list, material summary, etc. So now let's take a closer look at various types of showing the same data, okay? Because the same data can be presented differently in various types of BOMs. For instance, in a complete part list, we see each part individually, while in material summary group, we see the parts grouped by the material. Yeah, so we can see LMDFs on the left, and the same components of the LMDFs will be combined together on the material summary on the right. However, you can see that despite the code of the material is the same, the color code is different. Yeah, so we have different laminate on top of those MDF boards. And if we have the same color code, we also check the thickness of materials. Okay, so we see the panels of 18 millimeters as well as 25 millimeters. And we count the total amount of such a material. Okay, now let's take a look at the template, how the template works. So the first column A is reserved for the technical information, specifying the template type and marking the start and the end of the tables for specific component types. As you may see, there are solids, board, laminated boards, etc. But in the final report, this A column disappears. So you can see that we have only the data structure without all this technical information that we saw in the column A. Something similar happens in case when we have the data in a template, but if this information is not presented in the model, then this data block will be skipped. For instance, our model doesn't contain parts made of a solid wood, so that's why this section is omitted from the final BOM. Within the template, we have a table start keyword followed by material type to be displayed. It works like a filter, so you can see table start laminated board. It means that we will collect only laminated board in this group, so we will iterate through all the components within our model and select only those that match the type of the material. Let's take a closer look at the table data description. Okay, table data description indicates the line that contains keywords that defines which data element should be displayed in that row. Okay, so basically see a list of keywords, and those keywords just brings the data out of the model. Above this line, you can find the column headers and table title, which will be replicated in the final BOM. So we see the name, laminated boards, and the same is written in the final output file. Column A disappears, so we see nothing here. The last row border defines the format for the final row. For instance, we can use a thicker line to frame the table. So you can see that we have a different format. Yeah, those cells on the top were outlined with the thinner line, and the last row marked with the thicker line, which is displayed in the final output file, the final BOM. So you can see this nice framing. The sum row is used to calculate a raw estimation of material utilization, and it's based on a simple mathematical sum of areas. So keep in mind that this is only approximation. If you need more accurate estimations, such as determining the number of worksheets needed, then you should use a nesting BOM. But that's another topic. That's probably a topic for another webinar, so let's skip this. Okay, so once you probably already notice, all those keywords starts from the table, table description, table last row border, and so on. So they define like table properties. Now let's take a closer look at the keywords. Okay, so in the final BOM, this technical column will be eliminated and leaving us with only the data determined by the keywords, such as material code, name, color, etc. So what you had in the template basically will be replicated here. And the cell format will also play a role here. So if you have bold text, it will be also displayed in a bold format and so on. On top of that, you can also apply some scripts in Excel. Yes, if you have your data formatted in need to be formatted in certain way, you can do this using scripts. In Woodwork BOM editor, you can define order information. This is not a property of the model itself. It's more like an order information. So we can include like code, customer name, a manufacturing date, and more information here. For instance, a similar unit can be sold like week after the original unit was produced. They can basically have similar geometry, maybe different colors, and different manufacturing orders because they were produced in different time periods. Woodwork for Inventor generates wealth of detailed information, including part and workpiece sizes, grain direction, oversize, edge banding thickness, and so on. However, if you need more specific data, you can add custom information to suit your needs. For instance, you can create custom parameter and assign it to the value. Yeah? So for instance, in this example, I just used a numeric parameter, call it my customer parameter, and assign 1000 as a value. But this can be binary parameter, true or false, maybe just text, so whatever you can imagine. So then we can set this as exported parameter. There's a check mark. You can enable this exported parameter. And in the next step, what you can do, you can open Woodwork for Inventor design settings, went to the BOM tab, and there on the left, you can type this custom my property name, like my custom parameter. Okay, and you can see that corresponding Woodwork keyword is generated on the right. Item, custom my property, and then the name of the property that you have just generated. Here you can enable the triggers to define when to exchange Woodwork for Inventor data and custom my properties. Note that both directions are possible. If you start typing in the custom my property field, then a custom keyword will be generated. And vice versa. You can type Woodwork keyword on the right and then define the custom my property. And on the bottom in the green area, you can say where when this mapping should be performed. Yeah, when you save the file, when you run BOM, when you do autoplot, and so on and so forth. So in our case, we just generated a custom parameter. Yes, and we keep it here. So the last step we need to do, we can define this parameter in our template file. And when we include this custom parameter in our template, then in the final report, we will see the value. Yeah, the parameter itself, the name of the parameter will disappear, but the value will be shown instead. So as you probably know, materials in Woodwork are grouped based on how they are calculated, by length for profiles, by area for boards, etc. For instance, MDF boards, glass sheets, and metal sheets belongs to the same group because they are all measured by area. So now let's tackle a practical task. Let's imagine that we need to filter out only parts made of glass. So to achieve this, we need to follow this path. First of all, we need to create a part-only type of bill of materials since we want to iterate through the parts. So the glass piece is not an assembly, it's just a part, so we need to use the part type of bill of materials. Then in the primary filter, we need to include only the boards because the glass belongs to the board type of material, so we need to include only the board. And then when we have this filter enabled, we need to increase its efficiency even further by utilizing a filter which takes only those board type materials that have GL name. And this GL name is a default convention used before a material replacement to actually mark those glass type of materials. So when you do a replacement, we still know the original name that this component had. So we can use this to our advantage. And finally, as a bonus task, we will display the item code as a barcode. Okay, so let's take a look how this can be done. Okay, so let's say that we have some model And we can take a material picker and pick the glass to witness that the material code, the original material code, is GL, which stands for the glass. Now let's open a BOM editor. And on the bottom, we have a tool that allows you to modify existing template file. So I can switch to the cutting part list and select the lines that I need. So I need the A1 cell, then table start, table end block. I can copy this selection, make a new spreadsheet, and paste the values here, like so. Okay, so now we can just make an order here, define the names, define the column width, like that, change the names, maybe adjust the width of the columns, just some cosmetics here. And also we can delete the columns that we don't need. For instance, say covers, yeah, because normally glass have no edge banding, so we can remove the cover. And now we can use the tool called keyword constructor, and we can start to type the data that we want to get. So we need to get items, fill workpiece, material, information. So we type item, fill workpiece, material, original, code. And you see that the data blocks are split by the dots. Yeah? So item.fillWorkpiece.material.original.code. And we can copy this value and paste it into the data table description in a brackets. So we can just place the brackets, opening and close bracket here, and then insert the keyword. Okay. So the keyword item fill workpiece material original code equal, and we can type the text GL. Yeah, so such a way it will look for this GL. Now let's go for the barcode, copy this barcode definition and paste it here in the empty column, yeah, the barcode. Now I can take the formatting from previous cell, just copy the formatting on those adjacent cells, and then say I want to define the width. Let's make it wider. Okay, the barcode takes some place, so we need to make it wider. Then we can merge the cells and center the value. Okay, and now finally we can paste the copied keyword here. Okay, and finally we need to define the height of those rows. So we can increase the height, so that's why we change the height. And in such a way, now the item barcode will probably fit. We need to have some spacing between those barcodes, and that's how the final BOM output looks like. So we can see that it filtered all the components except only the glass panels. And here we are. So we have a glass of certain thickness, the quantity, length, width, and there's the barcode framed nicely. So we have a chance to just target with the laser and get the info about the item. To further extend capabilities, Woodwork offers a material API that allows you to adjust or swap materials, change the grain direction, and apply the oversize. So the typical use of this functionality is configurator. So if you use something like, say, repetitive components, you can use the API in order to automate those tasks. Beside that, we also have material replacement. So this one allows you to use external database to get the codes and the names out of it. Yeah, so we can take the existing, say, SQL DB and then utilize the data to define codes and names for the materials for the replacement. And finally, once we have done all the side tasks, we can get all the model data. We can export all the model data to external databases, okay, in order to have a seamless data integration and management with the external database. Yeah, so we not only can get initial material codes and names from your DB, we can combine them with the sizes of the parts, and we can get a final report sent back to your database. That's all the information I wanted to share with you today. I hope that this was useful. Again, this was not a tutorial, this was like a conceptual explanation. And we will be happy to see your executives at our next webinar on the 30th of January. So if you have any questions about Woodwork for Inventor, feel free to contact us using the email provided below. Thank you very much for joining us today, and we are looking forward to seeing you at our future events. Thank you, good luck, have a nice day.